Then we look at two identical planets. Two identical planets, each with surface gravity g and volume v, coalesce into one planet with volume 2v and surface gravity of the new planet is 2g. It means there are two Earth, identical planet lah, not Earth lah. The condition is similar to that of the Earth lah. So we have two planets, and these two planets they collide with one another and merge into a bigger planet. So they ask you, if these two identical planets merge into one, so can I say that the gravitational attraction of this bigger planet is twice that of the original individual planet? Is it true? So I'm going to show you that mathematically it is not true, or why it is not true, right? So answer is not true, and I'm going to show why it is not true. Now again we quote this formula. The G is capital G, the universal gravitational constant, and the mass of the planet divided by the radius of the planet. Of course, if they use G, that means it is a similar condition to that of our Earth. So I safely say that it is like the mass of the Earth and the radius is like the radius of the Earth, right? So this is one of the original planet. The G is like this. But when the two identical planet they merge together, the mass is no longer m, but the mass of the new planet is 2m. The volume of the new planet is no longer v, but it is 2v. So let's say it is something like this, like this. Okay, right. So I copy and paste, right? So I have two identical planet, right? The two identical planet merge together and they become a new planet like this. Let me use a different color. Use a different color. Let's see, green color. Okay, it's the same. Let's say this one blue color, then this one I use blue color, right? Okay, right. So I use blue color. So we have two identical planet. One is this, right? With radius r, mass is me, and volume is capital V. Merge with another planet like this, radius r, mass is me, and the volume is V. So these two blue color identical planet, I merge them together to form a new bigger planet. Now this new bigger planet, I put it green in color, and the mass is now twice, or the sum lah, the sum of these two individual planet, which is 2m. The volume of this new planet is the sum of the volume of these two identical planet, which is 2 times the volume. So far you understand what is happening, right? Two of them like that merge, then become like this. Okay, so I cannot compare like this without looking at the radius. The reason is because the gravitation depends not only on the mass but also on the radius of the planet. So this old planet, these two identical old planet, they have radius r. But what is the radius of the new planet? We don't know. So if we don't know the radius, we cannot simply compare. So now my aim is to find out what is the radius of the new planet. What is the radius of the new planet? So I'm going to use the volume of a sphere. Now we know that the volume of a sphere is 4 over 3 pi r cube. 4 over 3 pi r cube. Okay, so this first equation describe the single original planet. Okay, now let's look at the new planet. The new planet, the volume is no longer V, but is 2V. So this one, the second equation refers to the new planet here, refers to the new planet here. And the volume is 4 over 3 pi r cubed. In order to distinguish the new planet from the old one, I put a small subscript 1 at the bottom. So the subscript 1 denotes the radius of the new planet, whereas the R is actually the radius of the old planet. Okay or not? So far, okay or not? I use the volume of a sphere. I form two equations. The first equation is for the old planet. The second equation is for the new planet. Not much difference. Only one is V and the other one is 2V. Okay, now I use equation 2 divide by equation 1. Equation 2 divided by equation 1. And you can see that on this side, the 4 over 3 pi and the 4 over 3 pi, they will cancel off. This 4 over 3 pi, 4 over 3 pi, they will cancel off. So I am left with r cube over r cube. So I have here r cube over r cube. The first r cube is the r1, is the new planet one. The second r cube at the bottom is the old planet. Oh, on this side, the v will cancel off. The v and v will cancel off when I divide. So I am left with 2. I'm left with 2. Okay, so a very simple equation here. But I cannot leave it as r cube, right? So I cube root. I cube root both sides of the equation. When I take cube root, the left hand side becomes r1 over r. But the right hand side becomes cube root of 2. So when I move the r over the other side, I found out that the new radius is not double the old radius. It's just cube root of 2 of the old radius. And if you use your calculator, you try to find out what is cube root of 2. Use your calculator and find out what is the cube root of 2. What is
Cube
the
root
cube
of
root of 2?
cube root of 2 would be, wait,
Cube root is 2 to the power of 1/3. 2, then you use the inverted v, then you bracket 1 over 3. 2, the inverted v, then 1 over 3.
1.25.
It's 1.259 or something like that.
Yeah, yes.
Okay, so we know that the radius of the new planet, I'm referring to here, the radius of the new planet is actually 1.26 that of the old planet. So you see, when I draw the planet, okay, the old planet and the new planet, it is not much bigger in terms of radius. This is 1r, this is 1.2 or 1.3 r. So it's the radius actually increased by a little bit only, but the volume become twice that of the old planet. Okay, so the volume actually increased by the radius only actually increased by 1.25 or 1.26 times. Okay, right. So this is the radius, but our gravitational pull does not depend only on the radius alone. Does not depend on the radius alone. It also depends on the mass. The mass. So now I use this equation here. I use this equation here. Okay, this one. So the G, it becomes the G for the new planet. So I don't want to put down G, I put there G1. I put there G1. This one is for the old planet, no? This one is for the new planet. Then the capital G is a universal constant. So it is the same. Now we come to the mass. The mass actually is ME for the old planet, but the new planet is 2 ME. Is 2 ME. For the old planet, the radius is R, but the new planet, it is 2 cube root of 2R. Now this cube root of 2R, you need to square it again. You need to square again. So it's better for me to take this number and put outside. The top number also I put outside. So the 2 comes from the mass. The 2 and 2 over 3 comes from the radius. So there are two numbers. One number come from the mass. One number come from the radius. So when you use your calculator to simplify, 2 divided by 2 to the power of 2 over 3. Again, it comes back to cube root of 2. So the new gravitational pull is cube root of 2 that of the old one. So it's actually 1.26 times that of the old planet. So this is how we prove it using mathematically, right? You have to form two equations, one for the volume, right? One for the volume of the old planet, one for the volume of the new planet. From there, you derive the relationship between the radius. So this relationship between the new radius, you substitute inside the radius. The mass also you substitute with twice the mass. So finally, the constant in front is cube root of 2. So it is not 2 times. When two planets merge together, the gravitation is not 2 times, but only cube root of 2. So it's actually 1.26 times. Although the two planet, each of them radius r, but when you merge them together, the new radius is not r. It's only cube root of 2 or 1.26 r. Similarly, the gravitational pull is only 1.26 times that of the old planet. Okay. Any questions so far? No question, right? So we move on to this last statement. 1 kilogram of gold would have greater value on Earth than on the moon. Okay, now this kilogram is actually the mass. It is the material, how much material that you have. It doesn't depend on the gravitational pull. The mass doesn't depend on the gravitational pull. So 1 kilogram of gold on Earth and 1 kilogram of gold on Moon, they have the same value. They have the same amount of matter. They have the same amount of material. So it will be the same, right? Unless you say the weight will be different because the weight depends on gravity. And that one I've shown you here. You remember this thing? I draw the spring balance and so on in our last lesson. So the weight, it depends on the gravity, but the mass, no. So 1 kilogram of gold would have greater value on Earth than on Moon is false. Both of them have the same value. Okay, 1 kilogram of gold on Earth has the same value of 1 kilogram of gold on Moon, right? It is not like the weight. It does not depend on the gravity. Any questions so far? No. Right. No, then we proceed